Welcome to Homework Lib.
Through the enantiomer of each of the compounds, we have two different options. One is going to be to straight up draw the specular image, meaning we're going to draw a plane over here and draw what would the mirror image look like. And the other more simple option is going to be to change one substituent direction on the original structure. And you need to do this for all chiral carbons. So we're going to follow the second procedure in order to get our results. So in the case for norepinephrine, what this is going to look like, I'm going to try to draw it as best as possible. What you're going to do is draw the same structure, everything the same, but the chiral carbons. So over here we have our OH here and OH here. And now the thing that is going to change is that in the original compound, the OH is looking forward. So on the specular image on the enantiomer, now it's going to be looking towards the back, NH2. Now we're going to do the same thing with dacogen. In this case, the atoms that we're going to change the orientation are going to be the ones on this fluorine ring. So let's start by drawing our fluorine over here. The first one that is going to change is going to be the nitrogen over here. The OH on this position now is going to be looking forward instead of backwards. So OH. The group over here is also going to be looking backwards instead of forward. And the rest of the molecule is going to stay the same because we're going to have no chirality on this case. Double bond, nitrogen, and single bond over here. Let me extend these guys, and we have our final structure. And for the last one, which is going to be the hardest, I'm going to do it down below for penicillin. Let me erase these instructions. Notice that the only thing that I changed is the direction on the chiral carbons. So the ones that are going to have chirality in this case are going to be the ones that I'm going to point in red, and those are the ones that we're going to change. So for penicillin, let me go a little bit below over here. What this is going to look like is, let's begin with, actually I'm going to begin with the square over here, just because it is going to be a little bit easier to continue drawing from there. So what we know is that the top left needs to be going towards the back instead of the front. So this is going to be our NH group. The top right, the sulfur atom, needs to be going also towards the back now. Now, over here, on the bonds that we're going to get, one of the methyl groups is going to be looking now towards the back. Oh, actually, in this case, this carbon is not going to be chiral because we have two substituents that are the same, right? So in this case, it really doesn't matter. We can leave it like that. Sorry, I missed that in that scenario. So the two methyl groups are going to stay the same. It really doesn't matter. You can change their configuration, but just for you to notice that this is going to have no effect whatsoever on the if it is an enantiomer or not. And finally, we're going to have the bond over here. Now it's going to be pointing to the front. And we have our OH double bond oxygen. Double bond oxygen. And now we can complete the structure on the left. Double bond oxygen. And our phenyl group over here. And with that, that would be the mirror configuration or the enantiomer for penicillin G. So with that, it would be all. Again, the advice is that you need to identify all of the chiral carbons, and then you can change the configuration of the substituent that is going to the front or to the back. You just switch it up, and now automatically you're going to get the mirror image. And this avoids, the whole thing of drawing like a mirror and making the specular image of the whole molecule, which sometimes can be complicated, and you can make some mistake by essentially by chance. Okay, and with that, it would be all.